Okay, so the recording has started, so let's dive into today's lecture. Okay. All right, so I hope you can see my screen. Can you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes, sir.
So I hope you remember what we discussed in the last class. In the last class we discussed about what algorithm is, how do you express algorithm. There are different ways you can express algorithms, and we also discussed the very idea is like why it is important to analyze algorithms. Okay, because good algorithms, okay, all right, are remarkably uh, faster algorithms or remarkably better algorithms than the ones that are not. So it's very important to analyze algorithm and separate the good ones from the bad ones, right, Nakina? Yeah. Okay. So what are we going to do today is we are going to discuss something called the sorting problem. So we are going to discuss a problem first. The problem is called the sorting problem. So let's just first understand and define what a sorting problem is. And after that, we are going to discuss one sorting algorithm today at least to solve this problem that we are discussing. Okay, so what is a sorting problem? Now this is how we are going to define a sorting problem. Now remember, hopefully you remember this one, that an algorithm takes an input sequence, right? It takes an input sequence and it produces some sort of output, right? Do you remember that, Nakina? Yeah.
Yes, sir.
Yes,
Okay.
sir.
Now I did mention that some algorithms do not take any input but produces output. ঠিক আছে? মানে an algorithm must produce output. It may or may not take input depending on what kind of problem we're looking at, right? Now, in case of a sorting problem, so let's imagine we are we are discussing a particular algorithm that solves the sorting problem. So it's a sorting algorithm. So what is a sorting algorithm? Some kind of sorting algorithm. There are many kinds of sorting algorithms. So let's say we are discussing a sorting algorithm. A sorting algorithm is one that solves the sorting problem. Now, in case of a sorting algorithm, it must have an input sequence and it also has an output sequence. Clear, Nakina? So it takes an input and produces an output. Correct, Nakina? Yes? Okay.
Yes, sir.
So what is this sorting problem? How do you define a sorting problem? In case of a sorting problem, the input is a sequence of numbers. Okay, sequence a1 to an of numbers. ठीक है? Okay, now it could be numbers, it could be characters, but let's say for the sake of defining sorting problem in our case, we define that as a sequence of numbers. So we provide a sequence of numbers. Is it clear, Nakina? For example, here's a sequence of number 2, 3, 5, 1, 4. That's a sequence of number. Clear, Nakina? Is that okay?
Yes, sir.
I
Yes,
provide
sir.
this as an input. Now, so the input is a sequence A1, A2 up to AN of numbers. So what is the length of this sequence here?
N.
N. So we are providing a sequence of length N. And what is the output that this particular algorithm is going to generate? Okay, the output is a permutation of the sequence that we have provided. That means it's not going to produce a different output. It's going to rearrange this output. It's going to be a permutation of this output, but this rearrangement will be in a specific order. So it's a permutation of the sequence that we gave as an input. So the output is a1 prime, a2 prime up to an prime, because we are rearranging the same n element array. So the output would also be an n element array, but there is a particular ordering that we have. What is the ordering? The ordering would be such that a1 prime is smaller than equal to a2 prime, and so on up to smaller than equal to an prime. So what is this order? In what order did we actually sort it?
Sir, ascending.
Sorry?
Ascending order.
Acha. Okay, ascending order, but a better term would be to call it a non-decreasing order. ঠিক আছে? Is it okay, Nakina? Yes?
Yes, sir.
Yes, sir.
If you say ascending order, I can take it in a loose way, but a better term would be a non-decreasing order. Now, why did I say a non-decreasing order is a better term than ascending order? I'll give an example. Okay, don't worry about that. Okay. Now, so a correct sorting algorithm would what would be the output that a correct sequence algorithm would produce? Therefore, for this input sequence, 1, 2, 3,
4, 5.
4, and 5. Correct, Nakina? Yes?
Yes, sir.
Yes, sir.
Okay. So here's an example. If the input sequence is 824936, the output is 234689. Is it okay, Nakina? Yeah?
Yes, sir.
Yes, sir.
Acha. So this is how we're defining a sorting problem. So what is a sorting problem? A sorting problem is one in which you have an input sequence of some n elements, and the output is a permutation of this input sequence such that it is in the non-decreasing order. Is it clear, Nakina? Yes?
Yes, sir.
Yes, sir.
Okay. Now there are a couple of things to actually make sure that we understand. Now, I say that this order is called a non-decreasing order. Of course, you can also call it an ascending order, but I did mention that the non-decreasing order is a better term than an ascending order. Why did I say so? What does the word ascending mean? Can anyone tell?
बाढ़ते से increasing.
Increasing order, right? Ascending means increasing order. So say I have an input sequence which is like this. So let me write down the input sequence, okay? And let me also write down the output sequence, okay? All right. So let's say the input sequence is 3, 1, 4, 3, 6, okay? What will be the corresponding output by a correct sorting algorithm?
1, 3, 3, 4, 6.
1, 3, 3, 4, 6. Now, the problem
1,
is
3,
if you call it a, yeah, so I haven't written anything different, right? Okay. The problem is if I call it an ascending order. Ascending mane hocche it should be in an increasing order. 1, 2, 3, has it increased? 1, 2, 3, has it
Yes.
increased? Yeah.
Yes.
3 to 3, has it increased?
No, sir.
No.
No. So when you say ascending order, and if you have got equal key values, then it doesn't really ascend all the time. Correct, Nakina? Yes?
Yes, sir.
Yes,
Yeah.
sir.
So if you say ascending order, it would be true, it would be correct if you do not have equal key values, right, Nakina? Yes?
Yes, sir.
Each of these values are said to be keys, right? So if you do not have equal key values, then that's fine. Okay, right? For example, here we have an input sequence 824936. No key values repeats. Okay, and therefore you see it's an absolute increasing order or ascending order. No problem. You get it right, Nakina? Yes.
Yes, sir.
But if you have equal key values, for example, here we have got 3 twice over here, then you see over here it did not increase. The sequence is not in an increasing order. In that case, if you say it's an ascending order or increasing order, I can accept it in a very loose way, but you see there's a problem, right, Nakina? Okay, so a better term, I would not say that I would completely reject or completely unaccept your the term ascending order. That's fine, I would probably accept it, but a better term would be a non-decreasing order, right, Nakina? Yes. Okay. Why non-decreasing order is a better term? Because you see, when I say non-decreasing order, I am trying to say that the order is not going to decrease. It can increase or remain the same. So you see over here, 1 to 3 increased, 3 to 3 remain the same, 3 to 4 increase, 4 to 6 increase. So it's non-decreasing. So this is a better term than just saying ascending order. Is it clear, Nakina? Are we good?
Yes, sir.
Yeah. So it's very important that we are when we define something, when we are saying something, it's very important that we are as correct as possible. Okay. So again, if someone writes ascending order পরীক্ষার খাতায়, I wouldn't probably cut any mark. But if someone writes non-decreasing order, okay, that's a better way of writing. So in any interview, for example, কে ইন্টারভিউ দিচ্ছে বা কেউ দিচ্ছে, ঠিক আছে, এরকম একটা অর্ডার, একটা স্টুডেন্ট বললো it's in increasing order, it's okay, but somebody say non-decreasing order, I have a better impression about that student because he's more correct. Is it clear? Yeah. Okay.
Yes, sir.
So I hope we have clarified what we understand by the sorting problem. Is it okay, Nakina? Yes.
Sir, due to its repeat values,
Is the reason why we're saying it's not decreasing.
Sir, say that again.
Due to its repeat values. That's why I'm saying
There is a storm going on when you're talking.
Oh,
when
sir,
you're
is
saying.
it better now?
Yeah. Bolan,
Okay,
about?
sir. Due to its repeating factor,
No,
that's why
it's
we're
not
calling.
due to the repeating factor. যদি আমি ইনক্রিজিং অর্ডার বা অ্যাসেন্ডিং অর্ডার মানে হচ্ছে the output মানে the next number in the sequence will always be larger than the previous number, right, Nakina? That's what ascending mean, right, Nakina? Yes.
Yes, sir.
Yeah, but when you have equal key values, তখন এই জিনিসটা exactly হয় না in some places, right, Nakina? Yes.
Yes, sir.
Yes,
তার
sir.
জন্য it's not a but it's okay if one says that, but it loses the meaning a little bit, তাই না? Isn't it? Yeah.
Yes, sir.
So that's why a non-decreasing order term is a better term to use. Are we okay, Nakina?
Yes, sir. মানে always ascending না আর কি এই জন্য।
Always ascending, but at least I'm saying it's a non-decreasing order. It will not decrease. Is it okay, Nakina? Okay. Are we good? So far, so good.
yes, sir.
Does anyone have any other point over here? No. Okay. So if no one has a point, I want to clarify one more point over here. Okay. Let's see that we understand this one very well. Okay. Acha. Some people can, there are many who can say, well, 824936. Let's say this is the input sequence. And let's say we have an algorithm which produces the output sequence, which is like this one. Let's say 9, 8, 6, 4, 3, 2. Will I say that this particular algorithm has sorted the sequence?
Yes, sir.
Yes, sir.
We will
Yes, sir.
not at the moment say that. ঠিক আছে? At this moment, we are defining the sorting problem as the one which is sorting in a which way? Non-decreasing order.
Non-decreasing way, sir.
Right? That's how we are defining the sorting problem. Is it okay, Nakina? Yes?
Yes, sir.
Yes,
Okay. That we want to be non-decreasing order. We want to be very, very strict to what definition that we are giving. ঠিক আছে? Is it clear, Nakina? Yes? Okay?
Yes, sir.
So এটাকে আমরা কি তাহলে কি sorting problem solve করেছি বলবো?
No, sir.
It has an order, but according to our definition, we will be very strict about it and we'll say non-decreasing order. Let's call it sorting order. Now you can give other terms to that, no problem. You can say it's reverse sorted, no problem. I'm not unhappy with that term. ঠিক আছে? Clear Nakina? Yes? Okay? Right?
Yes, sir.
আচ্ছা
Yes, sir.
এখন আপনি এভাবেও ডিফাইন করতে পারেন let's define a sorting problem as a one as an algorithm that's going to sort by sequence in a non-increasing order. Then this would be the correct sorted order. তাই না নাকি না? Yeah, but what I'm just trying to say is you need to give a definition and need to stick to that. ঠিক আছে? Okay, so let's give this as a definition and let's stick to that. Is it okay নাকি না? Are we good?
Yes, sir.
ঠিক আছে? আচ্ছা। Okay. Now that we defined what a sorting problem is, let's try to discuss how to solve the problem, right? Okay. So in order to solve the problem, we need algorithms. We need strategies to solve the problem that we have just defined, right? Nakinai, are we good with
Yes,
that?
sir.
Yeah. It turns out a sorting problem is a very old problem in computer science in algorithms, right, Nakina? And as a consequence, there are many sorting algorithms. Some of the sorting algorithms you may have heard of include bubble sort. Have you heard of the name bubble sort?
Yes, sir.
Yes, sir.
Yes, sir.
You have. Have you heard of insertion sort?
Yes, sir.
Yes, sir.
Do you know what insertion sort do? How does insertion sort sorts? Naki, have you just only heard the name? Which ones?
Yes, sir.
We did it, I think, in CSC 2 to 5.
Oh, আচ্ছা ঠিক আছে
Yes, sir.
দেখবো কতটুকু জানেন ঠিক আছে কুইক সর্ট কুইক সর্ট
No, sir.
Yes, sir.
না স্যার
Quick sort, I heard it, sir.
নাম শুনেছেন ঠিক
Yes.
আছে তো আচ্ছা মার্জ সর্ট
Yes, sir.
Yes, sir.
স্যার
আচ্ছা পারেন মার্জ সর্ট
Yes, sir.
আচ্ছা, okay, bucket sort,
No, sir.
shell
sir.
sort,
No, sir.
আচ্ছা, and we have more many more sorting algorithms, ঠিক আছে? Okay, আচ্ছা, so there are many sorting algorithms, but remember all these algorithms have the same purpose, right? নাকি না? Yeah, what is the purpose? The purpose is to solve the sorting problem, right? নাকি না? Are we good?
Yes, sir.
Now one can say এত algorithm শিখে কি লাভ? They all do the same thing. Let's not just learn one of them and that's it, done, ঠিক আছে? No, that doesn't happen that way, because all these algorithms, they have different properties. They may do the same thing, but they have different interesting properties. So it's very important to actually understand these algorithms in details, okay? Right? So they have different properties, they have different performances as well. They don't perform the same way, right? Okay, right? Insertion sort doesn't perform the same way as merge sort, right? Merge sort does not perform the same way as quick sort, right? Yeah, okay. Certain applications দেখা যাবে one kind of sorting algorithm is more suited. Certain other kind of application দেখা যাবে other kinds of sorting algorithm is more suited, okay? So it's not like you need to sort it, just take a random sorting algorithm and apply that. No, you need to be very methodical, you need to be very clear, you need to be that these are important things, and these things only when you understand these algorithms in details. Is this okay? Does it make sense?
Yes, sir.
Okay, let me give an example. Let me just give when I say that these sorting algorithms differ in terms of performance, that I guess many of you can agree, ঠিক আছে? But when I say these sorting algorithms may have different properties as well, you might wonder what kind of properties they may differ in. Okay, let me give an example of a property that these algorithms can differ in. Okay, right. So you see over here, some of these algorithms are written in bold font. Can you see that, Nakina? These algorithms?
Yes, sir.
Yes, sir. Yes.
These algorithms are said to be stable sorting algorithms. What are they called? Stable sorting algorithms. So that's why I have also put the word stable in bold font as well. Okay, these are stable sorting algorithms. There are other algorithms here, like for example here, let me put a dot, like quick sort or shell sort. They are not being put in a bold font because they have a different property, and in fact these are unstable sort algorithms. ঠিক আছে নাকি না? Now you might say, oh, so what is a stable sort algorithm? What is an unstable sort algorithm, right? Does it mean unstable sort algorithm do not sort? Why is it unstable? Now, both stable and unstable sort algorithm sorts, but they have different properties, a slightly different property. So let me explain what is a stable sort algorithm. So here is the definition of a stable sort algorithm. What it says that a sorting algorithm is said to be stable. You'd call that sorting algorithm stable if you have two objects with equal keys that appear in the same order in the sorted output as they appear in the input array to be sorted. Is it clear? Hold on, okay, now. Achha, let me explain this one. Okay, so I would call a sorting algorithm to be a stable sorting algorithm. So let me give an example of a stable sorting algorithm. ঠিক আছে? Stable. So I'm not giving an example of unstable sorting algorithm. So I'm giving an example of what a stable sorting algorithm would do. Is that okay, Nakina?
Yes, sir.
Okay. Let's say I give an input sequence. Let's say the input sequence is 3, 1, 2, 4, 3, 5. Is that okay? That's the input sequence. Is that all right? Okay. So tell me, what output sequence would it produce?
1,
1,
2, 3, 4, 5.
4, 5.
1, 2,
Three,
3, 3, 4,
4, 5.
5.
4,
Correct?
5.
Yeah? Okay?
Yes, sir.
আচ্ছা, এখন একটা ইন্টারেস্টিং জিনিস দেখতে হবে এখানে। a sorting algorithm is said to be stable. When would I call the sorting algorithm stable? If we have two objects with equal keys. Do I have any of these, any object over here with equal keys? এখানে কি equal keys repeat করেছে?
Yes, sir.
Three.
Yes, sir. 3.
Yeah, 3 and 3. That's why we have got 3 and 3 here, right? আচ্ছা, here's my question. Which 3 is this 3? Is it the first 3 or is it the letter 3? Which one?
First 3.
How do you know
First
that?
three, sir.
How do you know that? Who said that? You don't
Stable.
know. You
Sir,
don't
এটা
know.
অ্যাকচুয়ালি এক এক অ্যালগরিদমে এক এক রকম হয়।
আসতেছে, you don't know. Like এটা যদি ফার্স্ট 3টা না হয় যে লেটার 3টা হতো আর এইখানে লেটার 3টা যদি আগেরটার ফার্স্ট 3 হতো, it's still sorted, তাই না নাকি না? Yes.
Yes,
জি স্যার
আচ্ছা, but
Yes, sir.
if I have an algorithm that guarantees you whenever you have an equal key, okay, এখানে আমি একটা কাজ করি, এখন এটাও 3 এটাও 3, এগুলোকে একটু ডিস্টিংগুইশ করার জন্য এই প্রথম 3টাকে 3 প্রাইম লিখলাম, okay? So that's easier for me to mark this one as 3 prime. So 3 prime is the first one, then 3 is the second one, okay? So if your algorithm guarantees the one in the equal key that appears first in the input sequence also appears first in the output sequence. তার মানে a relative order in the input sequence is maintained in the output sequence as well. এটা যদি guarantee করতে পারে এই algorithm, then that's a stable sorting algorithm. Is it clear নাকি না? Yes?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Now, if you read it again, it will make sense now. I said what? I say a sorting algorithm would be said to be stable if we have two objects. I could have more than two objects as well, no problem. But if we have, let's say, two objects at least with equal keys appear in the same order in the sorted output as they appear in the input array to be sorted. So that relative order of the equal keys is maintained in the output sequence as that in the input sequence, right? If your algorithm guarantees you that, that is a stable sort algorithm. Clear, Nakina? Is that okay?
Yes, sir.
Yes,
Yes,
sir.
sir.
And interestingly, you see all these algorithms like bubble sort, insertion sort, merge sort, bucket sort, all of them would do that, okay? This algorithm would actually ensure that this happens. But there are other sorting algorithms like quick sort, maybe shell sort, okay? And we'll learn some other sorting algorithm as well. They may not, okay? They may not. Now, they will not guarantee you that. And that's why they are called the unstable sort algorithm. So you can see all of them are sorting algorithm. এটা stable sorting hook or na hook, it doesn't matter. It still sorts it, right, Nakina? Yes? Okay. Yet they differ in terms of properties. Can you see that? They differ in terms of properties as well. Yes? ঠিক আছে? আমরা clear Nakina? Yeah?
Yes, sir.
Okay. So that's what I'm saying. There, I have various sorting algorithms. True, there are various sorting algorithms that solve the same problem. Now, when I say that, what if someone says, "Hey, after algorithm for Kilab, just take one of them and just solve them"? No, they have different performances. They also have different properties as well. Okay? So it's very important for us to understand these things. Okay? All right, are we clear, Nakina? Is that okay?
Yes, sir.
Yes, sir.
Okay, here's an example. I think it's a very pictorial example, very nice example. Okay, so say we have got, this is the input sequence 10, 20, 20, 30, 10. So is it sorted or unsorted?
Sorted.
Unsorted.
Sorted কেমন হলো? 10, then about 20, 20, about 30, about 10 হয়ে গেল। Unsorted, right now? It's an input sequence. Let's say we use a stable sort algorithm, not an unstable sort algorithm, stable sort algorithm. If we use a stable sort algorithm, this is the output sequence that will be generated. Okay, 10, 10, 20, 20, 30. Is it sorted?
Yes, sir.
Yes, sir.
Not only that, you see some interesting things here. Like, look at here. The green 10 appears before the orange 10 in the input sequence, right, Nakina?
Yes, sir.
In the output sequence as well, the green 10 appears before the orange 10. Can you see that, Nakina?
Yes, sir.
In the input sequence, the orange 20 appears before the green 20. And you can see over here, the orange 20 appears before the green 20 in the output sequence as well. That would be only possible if you're using a stable sort algorithm. ठीक है? Is it clear, Nakina? Okay.
Yes, sir. Clear.
If you're not using a stable sort algorithm, this is not guaranteed. It could happen that the orange 10 could come before the green 10. Could happen. Or maybe the green 20 appears before the orange 20. That could also happen. Right? Yeah. But if you use a stable sort algorithm, it would make sure that if you have equal keys, the relative order in the input sequence is maintained in the output sequence as well. Is it clear, Nakina? Are we good?
Yes, sir.
Okay. So we understand what's the stability of a sorting algorithm. Right, Nakina?
Yes, sir.
Okay. Now, today we are going to learn one sorting algorithm. আজকে আমাদের কাছে একটা sorting algorithm শিখা। And the sorting algorithm that we are going to learn is something called the insertion sort algorithm. Right, Nakina? Yeah. So this is our first sorting algorithm, our first algorithm that we are learning in a very formal setting. So we are going to learn about insertion sort algorithm, and we're going to see how does this insertion sort algorithm work. Is it clear, Nakina? Does anyone have any question before I start with the insertion sort algorithm? Anybody having any questions regarding insertion sort algorithm? And regarding other things? If you don't, we can start with insertion sort algorithm. Are we good?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so let's start with the insertion sort algorithm. Okay? Okay, just give me a minute. Let me just put my laptop on charge as well, because I do not want to charge my laptop in the middle of the lecture. Okay, let me do that, and then I'll come back to insertion sort. Okay, give me a minute. Okay, I'm back. All right. So can you hear me now?
Yes, sir.
Okay, let's look at what is it, how does this insertion sort algorithm work? Okay, the entire lecture. Okay, we have got more than I guess like something like how much 45 minutes or something like that we have, right? In the next 45 minutes, we're just going to discuss insertion sort, nothing else. Okay, but we want to do it. We want to ensure that we understand it thoroughly. Okay, so I'm going to first look at the structure of this algorithm. Don't worry about what this algorithm is doing. First, I'm going to look at the structure of the algorithm, and we are happy with the structure of the algorithm. Once we see the structure of the algorithm, the next thing we're going to see is we're going to see whether this algorithm works or not. So again, don't worry about how does it work, but we're going to see whether we are convinced with the fact that this works or not. Okay? Once we understand that as well, once we're convinced that this algorithm works, it sorts, okay, then we will attempt to understand, okay, what is the design philosophy of this insertion sort algorithm? Why does it work? How was it developed? What was the thing that we had in mind? What was the thing that the insertion sort algorithm inventor had in mind when he was developing this algorithm? So we'll try to assess that as well. Okay, clear, Nakina? Is that okay? Are we good?
Yes, sir.
Yes, sir.
We're going to spend 2 classes on insertion sort algorithm because it's the first algorithm we're trying to learn formally. That's what we're going to do today. And in the next class, the entire class, we are going to discuss the performance of this algorithm. Okay, we're going to discuss how to analyze the performance of insertion sort algorithm. Okay, but that's in the next class, so let's not worry about it today. Okay. All right. So first, the structure. Let's look at the structure. Look at this one. First, here's the pseudocode. Here's the name of the algorithm that we have said. So this is the procedure name. The name we called it the insertion sort. Okay. And how many input does it take? How many input does the algorithm take?
1, sir.
1, which is this one, right? Okay, it takes the input using as an argument, right? So
Yes.
the input is A. A is the array. So for example, if my array is something like this, let's say, okay, 8, 2, 4, 6, 3, 9. Is it sorted or unsorted?
Answer.
Unsorted. That's the array. So I take the algorithm takes this array as an input, right, Nakina? Yes, and it's going to sort this array. Is it clear, Nakina? Are we good?
Yes.
Yes, sir.
Okay. Right. So that's the first thing. Okay. Acha. The array has indices going from 1, 2, 3, 4, 5, and 6. Correct, Nakina? Yes.
Yes, sir.
So what is A1? Can anyone tell me what is A1 in this example?
8.
8,
8. And what is A3?
4.
4.
4. So that's for sure you understand that. Then Nakina, yes? Okay. একদম
Yes, sir.
basic programming. ঠিক আছে. Okay. এখানে গিয়ে অনেকে কনফিউজ হয়ে যায় যে স্যার আপনি তো একটা মারাত্মক ভুল করলেন। The starting index of an array is 0. এটা কার কার মনে হচ্ছিল?
Sir.
Okay, অনেকের মনে হচ্ছিল না মাঝখানে when I was writing the starting index is 1, then 2, then 3. অনেকের মনে হচ্ছিল না I should start this index from 0, then 1, then 2, and so on, right? এরকম আসছিল তো খেয়াল নাকি না? Yeah? Okay.
Yes.
Yes. Now, whenever we are going to write pseudocode, in most of the cases, when I'm dealing with an array, I'm going to, take the first index as 1, starting index as 1. Now, what if I take the starting index as 0? No problem. That's also okay. But starting index 1 যদি কেউ লেখে, it's still valid. Okay? Is it clear? Are we good?
Yes, sir.
Acha. Now, let me try to explain you why if we write the starting index as 1, it's still okay. Many of you may have this question in mind, but you're just either too scared to articulate it to me, maybe. Okay, maybe some of you are saying, কেন দরকার কি ছিল মাতব্বরি করার তো দরকার নেই আমরা সারা জীবন পড়েছি array starting index is 0, why all of a sudden 1 দিয়ে start করছি, what's so fancy about it? তাই না নাকি না? Yeah, okay. The reason behind that is, first of all, understand যে all programming languages do not start with a 0 in an array. I mean, all programming languages do not start with an index of 0 in an array. Okay, so there are several languages, like for example there are some languages called zero index languages. Okay, all right. Okay, and there are many other languages as well, programming languages as well, which are called the one index programming language, right? Yeah. So what does zero index programming language mean? Zero index programming languages mean each of languages when you have an array, the array first index, the start index is 0. Our one index languages means each of programming languages, the starting index is actually 1. Examples of zero index languages, and most of the languages you guys learned are all probably zero index languages, like C is a zero index language, right? C++ is a zero index language. Java is a zero index language, etc. Right? These are the languages you guys have learned, right? But do bear in mind there are other programming languages which are not zero index languages. For example, have you ever heard of MATLAB?
Yes.
Yes, sir.
Yeah, in MATLAB, in case of an array, the array index starts from 1. Have you heard of a programming language called Julia? Anybody heard of that, Julia?
Maybe.
Maybe? What do you mean by maybe? It's not a Hollywood movie. This is a programming language, okay, called Julia. Now that also is a one index language, okay? So the index, the starting index starts with 1. Is it clear, Nakina? So, এমন কিন্তু না যে your the starting index should start with 0. It varies from one language to another language. And যখন আমরা pseudocode লিখি, do we need to be language specific?
No, sir.
No, sir.
No.
No, sir.
So that now establishes the fact আমি 1 দিয়েও করতে পারি, 0 দিয়েও করতে পারি, it doesn't really matter. Is it clear, Nakina? Are we good with that? Yes? Okay?
Yes, sir.
আচ্ছা, এখন bear in mind এটা যদি আমি না বলতাম এটা হয়তো বা আপনারা জিজ্ঞাসাও করতেন না, তাই না, নাকি না? Yes? So whatever I say, whatever I write, whatever I say, যত কিছু বলি, I have logic behind that. So if it sounds a little weird, ask me. Then and then, sir, এভাবে কেন করলেন? ঠিক আছে? There is definitely some logic to whatever I am doing. ঠিক আছে? Is it clear নাকি না? Yes? Okay? So
Okay, sir.
don't feel frightened. Don't feel shy about it. ঠিক আছে? Okay? Right? Okay? I am happy to spend my time discussing these concepts because these are the insights. Okay? All right? Okay? No problem. Don't worry about that. So whatever I say has logics behind that. So if you find something that is that you're not really clear of, ask me then and then. So are we good with that, Nakina? So far so good?
Yes, sir.
Yes, sir.
Okay, let's look at the structure. So let's look at the structure. Here's a for loop, right, Nakina? Yes, for. Are egola sab ki indented na?
Yes, sir.
So all these things are a part of this for loop. Is it right, Nakina? Yeah. Okay. I'm not going to put any braces to mark the scope of the for loop. Is it clear, Nakina? Yeah.
Yes, sir.
Okay. What is this mean?
Comment.
Comment.
Comment. So this would be ignored when I, when you execute this algorithm, right, Nakina? Yeah. Okay.
Yes, sir.
Here's a while loop. While loop under a kun lines গুলো আছে বলেন তোমাকে?
6 and
6 to 9.
6 to 9. 9
7.
will be sir.
6, 7.
6 and 7. And 6 and 7 are indented. So these are inside the while loop. 8 has the same, is at the same level as that of while. That means this is a part of for loop, but not a part of while loop. Is it okay, Nakina? Clear?
Yes, sir.
So that's about the structure of the algorithm. Structure নিয়ে সবাই clear কিভাবে algorithm টা লিখেছি, readability and stuff like that. Yeah.
Yes, sir.
Good. So we understand the structure. Now the second thing that we're going to now look into is we want to see that this algorithm works. ঠিক আছে? এই অ্যালগরিদমটা যে কাজ করবে মানে it solves the problem. ঠিক আছে? We want to see that. We want to be convinced with that. So let's say we have an input sequence 8, 2, 4, 9, 3, 6. So what I'm going to do is I'm going to run this input sequence, okay, on this algorithm, and we're going to trace it, and we're going to see whether this is going to work or not. Okay? Yeah. So right now I am not trying to explain you how does this algorithm work. I'm just trying to see যে আচ্ছা আমাদের input sequence দিয়ে দেই, and if we run this algorithm, okay, does it work or not? Is it clear নাকি না? Yeah. ঠিক আছে? Okay?
Yes, sir.
Okay, let's do that and let's see whether we are convinced with that or not. So let me open up a paint. Okay, let's paste that. Okay. All right, let's reduce the size a bit. Okay. Crop that. Okay. Right, good. Okay, so here's the algorithm, right? Yeah. Okay. So what I'm going to do is now I'm going to take an array. I want everyone to see this one carefully now. Okay. Here's an array that we have. And let's give an input to an array. Let's provide an input to this array. Okay. So let's say that the array is like this. Oh, sorry. Okay. 8, 2, 4, 9, 3, 6. That's the input sequence. Is it okay, Nakina? Yeah?
Okay, sir.
Is it sorted or unsorted?
Unsorted.
Unsorted. So these are the indices that we have. ঠিক আছে? Is it clear, Nakina? Are we good?
Yes, sir.
Okay, good. I want to make sure that this input sequence that I've given is the same as this one so that you can compare later on. Okay, yeah, this. So 824924936. Okay, now I want everyone to follow what I do. Okay, এখন কিন্তু আমি অ্যালগরিদমটা কিভাবে কাজ করছে মানে অ্যালগরিদমটা এভাবে কেন লিখলাম, এটা কিভাবে কি করছে, I'm not talking about that. I'm just going to follow the algorithm and I'm going to see whether it's going to মানে solve the problem or not. Okay, আচ্ছা, so there's a for loop. For loop starts with j equals to 2 up to the length of the array. What is the length of the array?
6.
6.
So j will go from 2 to 6. So what is j? J is therefore some sort of variable
Variable.
whose initial value is 2. Is that clear, Nakina? Yes.
Yes, sir.
Yes, sir.
Okay. So after each iteration, the array contents will get updated. So let me just every iteration পর array value গুলো কি হবে, updated array value গুলো I'm going to write it again and again so that you can see that after every iteration array content গুলো কি রকম ভাবে change হবে. We'll see that. Okay, so I'm going to redraw this array. ঠিক আছে? Okay, let's see here. So let's start. For j equals to 2, so what is the initial value of j?
2.
2. Okay, and let's check the condition. Condition is j will go from 2 to 6. So is the value of j between 2 and 6? Yes. Okay, so the condition is true, so I will go inside the for loop. Is it okay, Nakina? Yes.
Yes, sir.
Now
Yes, sir.
I'm in line number 2. In line 2 I said key equals to aj. So what is key? Key is therefore another variable. And what is the value of this variable now? Key equals to aj. Aj, what is j?
2.
It's 2.
What is j? 2. A2, what is A2?
2.
2. So the value of key is now 2. Correct, Nakina? So I copy that value and store it in the variable called key. Is that okay? Yeah.
Yes, sir.
All right, line 3 is a comment, so I'll ignore it. Let's not worry. Go to line 4. What does line 4 say? I equals to j minus 1. So we now have a new variable called I. Correct, Nakina? Yes?
Yes.
And so what is the value of I? J minus 1. So what is j?
1.
2.
What is j?
2.
Answer my question. Take it. J is 2. 2 minus 1 is 1, so that's 1. Correct, Nakina? Yes?
Yes, sir.
Okay. Now I'm going to go in. Now I'm going to assess if this condition that we have is satisfied or not. If the conditions are satisfied, I'll go inside the while loop. Okay. Now look at this one. There are two conditions here. Okay, this one and this one. And there is an AND operation between them. We're doing an AND operation between them. That means in order the condition is satisfied, in order for me to go inside the while loop, both the conditions needs to be satisfied. Right, Nakina? Yes? Because
Yes.
there is an AND operation there. If it happens that one of the conditions is satisfied, but the other is not, so then it's not true. So I'll break the while loop. Right, Nakina? Yeah?
Yes, sir.
Yes, sir.
Okay. Let's check. Is I greater than 0?
Yes, sir.
Yes.
Yes,
Yes,
I
sir.
is 1 and 1 is greater than 0. No problem. So condition 1 is true. A of I. Is A of I greater than key? What is A of I? I koto.
1.
1.
1.
I is 1. So what is A of I?
8.
A of 1.
8.
A of 1 is 8. Right. Is 8 larger than key? What is key?
2.
2. Yes, 8 is larger than 2. So that condition is also satisfied. Right, Nakina? Yes?
Yes,
Yes,
sir.
Yeah. Since both the conditions are satisfied, I'll go inside the while loop. Right, Nakina? Yeah?
Yes, sir.
Yes, sir.
Now look at this one. Understand line number 6 very carefully. A of I plus 1 equals to A of I. তার মানে কি? এর মানে হচ্ছে A of I means ith position এ যেই ভ্যালুটা আছে, in the ith position এ যে ভ্যালুটা আছে, I'm going to store it in I plus 1th position, right? নাকি না?
Yes, sir.
তার মানে I plus 1th position মানে কি? ith position এ যেটা I plus 1th position মানে হচ্ছে to the right of it, right? নাকি না?
Yes, sir.
Yes, sir.
So I'm going to take the, I'm going to take this, let's say, value in the ith position, and I'm going to store it in the I plus 1th position. I'm going to take it to the right of it. Okay. So ith position e ki ache? I koto?
1.
1.
The I equals to 1. Position 1 e ki ache?
8.
8. I'm going to take it to the next, to the right of it. তার মানে second position এ 8 কে নিয়ে গেলাম। Clear না কিনা? Is that okay?
Yes, sir.
Yes, sir.
Good. And then what I'm going to do in line 7? I'm going to decrement I. If I decrement I, what would be the new value of I?
0.
0. Agreed? Nakina.
Yes, sir.
Okay. After line 7, where do I go? I'm done with
Again,
that.
the while loop.
I'll go back to the while loop, right, Nakina? Because it's a loop. Now, in a loop, it says, is I greater than 0? Is I greater than 0?
No,
No.
sir.
Yes, sir.
No, it is not greater than 0. So it is false. And you know it's an AND operation here. So if one of the conditions is false, the entire condition becomes false. So it will break the while loop and I'll go to line 8. Correct, Nakina?
Yes, sir.
Yes, sir.
Okay, so when I go to line number 8, what do? A of I plus 1 is key. So what is I?
0.
0. So what is I plus 1?
1.
1,
So A of 1A, what am I going to store? Key. What is key?
2,
2. So A of 1. A of 1, this is where I'm going to store 2. Am I correct, Nakina?
yes, sir.
Yes. Yes.
Okay. The rest of the things are as it is, so these are unchanged. Okay? Clear, Nakina? Is that okay?
Yes, sir.
So,
Yes, sir.
this is my updated array. Now, this is no longer, the array no longer is like this, where this is my updated array when j equals to 2. Correct, Nakina? Yes? When j equals to 2, this is how my array looks like now. Is it okay, Nakina? Yes?
Yes, sir.
Yes, sir.
Good. So after line 8, what do I do now?
Go back to for loop.
Go back
Line
to
number
for
1.
loop. We go back to the for loop. But before we go back to the for loop, we must do something else. What is that? Because before we go back to the for loop and check the condition, we must do something else. What is that?
Increase value of j by 1.
Yeah, increment the value of j, right? For loop যখন run করি, for j equals to 2 to a dot line. It's actually, if you write it in C or Java, it would be like for j equals to 2, j less than 6, less than equal to 6, j plus plus, right, Nakina? So I must increment j. So what is the new value of j?
3,
3, sir.
So now, when j is 3, I must run another loop, right? Okay, and I must run the loop, and this might change my array content. So let me just draw again the array. So we want to see what happens to the when j equals to 3, তখন array content কি অবস্থা? We would like to see that as well, right, Nakina? Okay, are we good? So j equals to 3, array content কি হবে? We'll see that. No worries. Okay. Now j is 3. So what is key equals to, sir? Aj. So aj, j is 3. A3. What is A3? Tell me that.
4. 4,
So
sir.
A3. Look at the latest one, 4. So key is now 4. Is that okay, Nakina?
Yes, sir.
Yes,
Key
sir.
is 4. Okay. I is j minus 1. So what is the new value of I?
2.
8.
J minus 1. J কত?
3.
3. 3 minus 1 কত?
2.
2. Okay. ঠিক আছে?
Yes, sir.
Yes,
Now
sir.
let's go to line number 5. Let's check this condition. Is I greater than 0? Is 2 greater than 0?
Yes, sir.
Yeah. And let's check, is A of I greater than key? What is A of I? What is I?
2.
2. So what is A of I? A of 2. A of 2 কত?
8.
8.
Is 8 greater than key? Key কত?
4.
4. So
4.
is 8 greater than 4?
Yes, sir.
Yes, sir.
Yes. So we will go inside the while loop. So both the conditions are satisfied. So I'm going to go inside the while loop, right, Nakina? Yeah.
Yes,
Yes,
sir.
sir.
So in the line number 6, you remember A of I plus 1 equals to A of I. তার মানে ith position এ যেই content আছে, I'm going to shift it to the I plus 1th position, right? Nakina? That means 2 is right. So ith position, ith position I কত? 2. So second position এ কি আছে?
8.
8. If I shift it to the right, so 8 এখন goes to position 3. Correct, Nakina? Yes?
Yes, sir.
Okay. And then I'm going to decrement I. So if I decrement I, what's the new value of I?
1.
1. Okay. And then what am I going to do now?
Going to while loop again.
Go back to the while loop to check the conditions. So let's check the conditions. I is greater than 0. Is I greater than 0?
Yes, sir.
Yeah, I is 1 and certainly it's greater than 0. Let's check the next condition. Is A of I greater than key? What is A of I? A of 1. A of 1 key.
2.
A of 1 is 2. Is 2 greater than key? Key kato?
4.
4. So is 2 greater than 4?
No, sir.
No. So one of the conditions is now false. Therefore, the entire condition, therefore, it does not pass this condition, right, Nakina? Yes. Okay. And so I'm going to break the while loop, right, Nakina? Yes.
Yes, sir.
Yes, sir.
When I go back, when I go and break the while loop, where do I go? To which line do I go to?
Line 8.
Line 8. And in line 8, what did we write over here? A of I plus 1 is key. I plus 1 koto? I did 1 high. I plus 1 koto?
2.
A of 2. A of 2 te ki thakbe key. A of 2 key. Ite ki thakbe key koto? 4.
4.
So 4 will be in A of 2. So this is A of 2. Correct, Nakina? Yes?
Yes,
Yes.
sir.
Good. Then what do I do now? I go back to the for loop, isn't it, Nakina?
Yes,
Yes, sir.
Okay. Now before I go back to the for loop, what do I do? I
Increase
should
J.
increment J. So J is now 4. Now, J should be between 2 to 6, but J is 4. Is 4 between 2 and 6?
Yes, sir.
Right. So the condition is satisfied. So I go inside the for loop. So the first thing is key equals AJ. AJ. J koto? 4. A4 koto?
9.
9.
9. So the new value of key is now 9. Correct, Nakina? Yes?
Yes, sir.
Yes, sir.
I is J minus 1. So what is J minus 1?
3.
3. J is 4. So J minus 1 is 4 minus 1. That's 3. Correct, Nakina? Yes?
Yes, sir.
Yes, sir.
Are you guys getting that? J minus 1, 4 minus 1 is 3. Or isn't your neural network firing? ঠিক আছে? Are we good?
Yes, sir.
Okay, no problem. Focus. ঠিক আছে? Are we good, Naki, so far, right? Yeah? Okay. So we have done that. Now let's check the while loop condition. Is I greater than 0? What is the value of I?
3.
Is that greater than 0?
Yes,
Yes.
sir.
Right, Shabash. You know some maths. Yes, 3 is greater than 0. Right? True. No problem. Then, let's check the second condition. Is A of I greater than key? Let's check that. I koto?
3.
3. So what is A of 3? A of 3 koto?
8.
8.
A of 3, sir. 8.
8.
Right? আচ্ছা সরি আমি একটা কাজ করি নাই সেটা হচ্ছে এগুলাকে অ্যাজ ইট ইজ ছিল রাইট নাকি না এগুলা লিখি নাই এখন যে কোসে 4 এর জন্য চেক করছি তাই না সো উইল সি হোয়াট হ্যাপেন্স এট জে কোস 4 রাইট নাকি না ইয়া
Yes, sir.
Yes, sir.
Yes, sir.
I did not do that then. Silly me. But that should be fine now, right? Okay. Okay, so আমরা কোথায় ছিলাম? স্যার আমি তো ভুলে গেছি। কই ছিলাম?
Sir, A of I is greater than key.
A of I greater than key. আচ্ছা, okay, let's see A of I greater than key. Let's check. I কত?
3.
A 3 কত, sir?
8.
8. Is 8 greater than key? Key is 9. Is 8 greater than 9?
No, sir.
No. So এখানে কি condition কি satisfied হলো নাকি unsatisfied?
Unsatisfied.
So the entire condition is now
False.
false. So am I going to go inside the while loop or am I going to break the while loop?
Break
Break
the
Break
while.
the 1.
Okay, I'm going to break the while loop and I'm going to say A of I plus 1 is key. So what is I?
3.
3.
So
3.
I plus 1 কত? 3 plus 1
4.
কত? 4.
4.
A of 4 এ কাকে রাখবো? Key. Key কত? 9. So
9.
A of 4 এ
9.
আমি 9 কে রাখছি। Correct নাকি না? Yes?
Yes, sir.
Okay?
Yes, sir.
And we're done. Now the rest of the things will remain as it is. So 2, 4, 8 and this is 3 and 6. Correct নাকি না? Yes?
Yes, sir.
And then I'm going to go back to the for loop, right নাকি না? Yes?
Yes, sir.
Before I go back to the for loop, I must increment
J.
J.
J, which is 5. So let me draw this array once again. So we want to see what happens when J is 5. So this is the array content. So let's see what happens. Okay. Are we okay so far?
Yes.
Yes, sir.
Okay. Don't worry. Don't worry about how it's working. First of all, let's check this one. Okay. J is 5. So J is 5. Now let's check. J should be between 2 to 6. Is 5 between 2 to 6?
Yes,
Yes,
sir.
Yeah. So that is the condition is satisfied. So I'll go inside the for loop, right, Nakina? Yeah.
yes, sir.
Okay. First thing, key equals to AJ. So what is AJ? J is how much?
5,
5. So what is A5?
3,
3,
3. So what is the value of key now?
3.
এটা ঠিক আছে আমরা নাকি না?
Yes, sir.
Okay. So next is line 4. Line 3 we will ignore it because that's a comment. Line 4. I is J minus 1. So what is the new value of I?
4,
4. Because J is 5. So J minus 1. 5 minus 1. That's 4. So let me write it here. Okay. Achha. Now I'll go to the condition over here in line 5 and see if both the conditions are satisfied or not. So first one is I greater than 0. I is how much?
4.
4. Is 4 greater than 0?
Yes, sir.
Yes, sir.
Yes. 4 is greater than 0, so it passes that condition. Let's look at the next condition. Is A of I greater than key? Okay, let's see. What is I?
4.
4. So what is A of 4?
9,
9. Is 9 greater than key? What is key?
3.
3.
Yeah. So is 9 greater than 3?
Yes, sir.
Yeah. So can I say that both the conditions are satisfied?
Yes, sir.
Yes,
So I'll go inside the while loop, right? Yes? Yes. So as I go inside the while loop, let's look at line number 6. What do? Ith position in J content ache, I'm going to take it to the I plus 1th position. That means to the right. So ith position ke ache, I ke. I koto?
4,
4th position ke ache?
9,
9.
I'll shift it to the 5th position, to the right. So 9 will shift to index 5. Is it clear, Nakina?
yes, sir.
Okay. Then after that, okay, I go to line 7. In line 7, I is decremented. So I is decremented, I is now 3. Correct?
Yes, sir.
Yes, sir.
I go back to the while loop and let's check these two conditions again. So first one, is I greater than 0?
Yes, sir.
Yes.
Yeah, I is 3, that is greater than 0, no problem. And is A of I greater than key? Hold on. A of I. What is I?
3.
3. So what is A of 3?
8.
8. Is 8 greater than key? What is key?
Yes, sir. Sir, 3, 3.
Key 3. So 8 is greater than 3. So that condition is also satisfied. Both the conditions are satisfied. So I'll go again inside the while loop, right?
Yes, sir.
Yes, sir.
Now when I go inside the while loop, I do something here. What is that? The ith position in jeta ache, I will shift it to the I plus 1th position. So ith position ki ache? I minus 3. Third position ki ache? 8. So I'm going to shift it to the 4th position. So 8 will go to the 4th position. Correct, Nakina?
Yes,
Yes,
sir.
Okay. After that, I should decrement I. If I decrement I, what's the new value of I?
2,
2. Again, I go back to line 5 to check these two conditions. Is I greater than 0? Is 2 greater than 0? Yes. Is A of I greater than key? Let's check. A of I koto?
2,
2. A of 2 tale koto?
4,
4. Is 4 greater than key? Key koto? 3. Is 4 greater than 3?
yes, sir.
yes, sir.
Yes. Again, the condition is satisfied. So again, I go inside the while loop. Right, Nakina? Yes?
Yes, sir.
Yes,
Are you guys following me? Nakina, ঠিক আছে?
Yes, sir.
Okay. Line 6. Line 6 ith position jeta ache, I'm going to take it to the I plus 1th position. So what is I? I is 2. Second position ke ache?
4.
4. I'll shift it to the 3rd position. So 4 will go to index number 3. Am I clear?
Yes, sir.
yes, sir.
Yes, sir. And then I'm going to decrement I. If I decrement I, what would be the new value of I?
1,
1. Very good. I go back to the while loop to check the conditions, right? Okay. Is I greater than 0?
Yes, sir.
Yes. I is 1 is greater than 0. No problem. Is A of I greater than key? Let's check. What is I?
1,
1. So what is A of 1?
2,
2. Is 2 greater than the key?
no, sir.
No. Okay, no. So thank God. Okay. So this condition has not, did not pass successfully. Okay, so একটা condition যদি ঠিক না থাকে, then the because it's ended, so this while loop breaks now, right Nakina? Yes.
Yes, sir.
So if the while loop breaks, where do I go?
Line 8.
Line 8. So what do I do in line 8? A of I plus 1 equals to key. So I plus 1 location, I'm going to insert key. Okay, what is key?
3.
3.
3. And what is I?
1.
1. So what is I plus 1?
2.
2. So I plus 1 is 2. The second index, I'm going to insert key. Key is 3. So I'm going to insert that key 3 in the second location. Is that clear, Nakina?
Yes, sir.
Yeah? Chikachi, right? Happy? So far, so good?
Yes, sir.
Is that okay? Yeah. So now we are done with line 8. Where do I go?
Line 1.
Line 1. But before I go back to line 1 and check the condition, what do I do?
Increment J to 6.
Increment J, so the new value of J is 6. Correct. Among the rest of the things in the array would remain as it is. So this is 2 and this is 6. Correct, Nakina? Yeah?
Yes, sir.
Now we're going to look what happens at J equals to 6. Okay? Let's see. So I'm going to redraw this one and we're going to see what happens now. Okay. Okay, is that fine?
Yes, sir.
Yeah. So let's check the condition. The condition says J should be between 2 to 6. Is it between 2 to 6?
Yes,
Yes,
sir.
Yeah. 2 to 6, when I say I mean 6 inclusive. So yes, it is 6. So it is, the condition is valid. So I go inside the for loop. When I go inside the for loop, line number 2, what do I do over here? I set the key to be equal to A of J. So what is A of J? J koto?
6.
6. So what is A of 6, sir?
6.
6. So the new value of key is now 6. Am I correct, Nakina?
Yes, sir.
Yes, sir.
Okay. And then line 3, I can ignore that because that's a comment. Line 4, I is J minus 1. So what's the new value of I?
5.
5. Very good. I'll write it here. So because J is 6, so 6 minus 1 is 5. Now let's go to line 5. Let's see if these two conditions are satisfied or not. Is I greater than 0? What is I?
5.
5. So is 5 greater than 0?
Yes, sir.
Yes.
Yeah. Let's check the second condition. A of I, is A of I greater than key? So what is I? I is 5. So what is A of I? A of 5?
9.
9.
9. Is 9 greater than key? Key is how much? 6.
6.
Is 9 greater than 6?
Yes,
Yes, sir.
Yeah. So I go inside the while loop. Now I come to line 6. And in line 6, what do? A of I plus 1 equals to A of I. So I take the ith, content in the array. And I, copy this to the I plus 1th location. So ith content ke ache? I koto 5. Fifth
5.
index ke ache?
9.
9. So where will I take this one to?
Right shift.
Okay, onto the index 6,
Index
right?
6.
Yeah. So this is where we will have 9. Correct, Nakina? Yes.
Yes, sir.
Okay, and then I'm going to decrement I. So if I decrement I, what's the new value of I?
4.
4. Very good. I go back to the while loop. Let's check again. Is I greater than 0? Is 4 greater than 0?
Yes, sir.
Yes. Is A of I got of 4. Is A of 4 greater than key? So let's check A of 4 ke ache?
8.
8. Is 8 greater than key? Key is 6. Is 8 greater than 6?
Yes, sir.
Yes. So I go inside the while loop because both the conditions are valid. So I go inside the while loop. And now here, I take the content in the ith location and transfer it to I plus 1th location. I is how much? 4. 4th location ke ache? 8. I will transfer it to the 5th location. So 5th location I can be 8. Am I correct, Nakina?
Yes, sir.
And then I go to line 7, the next line, where I is I minus 1. So what is the new value of I? 3. Okay. Go back to the while loop. Let's check the condition. Is I greater than 0? Is 3 greater than 0?
Yes, sir.
Yes. Okay. Is A of I greater than key? Let's check. I hoche 3. A of 3 koto?
4.
4.
4. Is 4 greater than key? Key হচ্ছে 6. Is 4 greater than 6?
No,
No,
sir.
sir.
No. So this condition is not satisfied. So it doesn't pass this condition. So it breaks the while loop. I go to line 8. Is it right?
Yes, sir.
So when I go to line 8, what do we do? A of I plus 1 is key. So what will happen? I plus 1 koto? I koto?
3.
3. I plus 1 koto? 4.
4.
A of 4A কে থাকবে? Key. So
Six.
A of 4A, this key will come. Key koto? 6. So I store that 6 in A of 4. Correct? নাকি না? Yeah?
Yes, sir.
Done. And then after we're done with this one, the rest of the things remains as it is. So this is 2, 3, and 4. Correct? নাকি না? Yeah?
Yes,
Okay.
sir.
And then what will happen? এরপর কি হবে?
J এর value increase করবো
Your
sir.
value increase.
It goes back to the for loop, right? It goes back to the for loop. And before you check the condition, you must increment J. So J is how much?
7.
7. Now let's check the condition of the for loop. The condition says J should be between 2 to 6. Is it within that bound?
No, sir.
No, sir.
No. If that is not within the bound, so what will I do? I'll break the for loop. And if I break the for loop, that means we terminate the program, right? Nakina? Yeah?
Yes, sir.
Okay. Now, those of you who come up to this one and get stuck, now what do? This is the end. No, the program must terminate, right? This is one of the properties of an algorithm. Remember from the last class, right? Nakina? Yeah. So we see that it breaks the for loop and the algorithm, the program terminates, right? Nakina? Yeah. Done. Is it clear, Nakina? Yeah.
Yes, sir.
Yes, sir.
Now, if you watch this carefully, this was the input sequence we started with, right, Nakina? Correct?
Yes, sir.
Yes,
Okay.
sir.
So the input sequence was 8, 2, 4, 9, 3, 6. Was it sorted or unsorted?
Unsorted.
Unsorted, right, Nakina? Yeah. And then after each loop, I showed you what would happen to the array. It's not that I have different arrays. It's the same array, but I just showed you that each loop what's happening to the content of the array. And finally, after the program terminates, this is the content of the array. So 2, 3, 4, 6, 8, 9. Is it sorted or unsorted?
Sorted, sir.
Sorted. So the output sequence is sorted. So here is my question. Does this algorithm sort, or does this algorithm do what it claims to do? Does it sort?
Sir.
Yes, sir.
Yes, sir.
Yeah. So I haven't yet discussed like what's the idea behind this sorting algorithm. I just took an example and ran this algorithm, traced that algorithm on that data, and saw that whether it actually does what it's supposed to do. So are you now guys convinced? If I say, are you guys convinced with this that this algorithm works? This algorithm does what it's supposed to do. Is it right, Nakina? Yeah.
Yes, sir.
Yes, sir.
Correct. এখন the next question that you would have is, why does it work? মানে এই যে অ্যালগরিদমটা বানানো হয়েছে, এই যে অ্যালগরিদমটা লেখা হয়েছে, what was going through the designer's mind? There was something that was going through his mind, তাই না নাকি না? Yeah.
Yes, sir.
Right. Okay. Okay. So we'll try to now look at that. Okay. All right. So shall we look at that? কারো কি কোনো questions আছে at this stage? Anybody has any questions at this stage? No? Okay. So if you don't have any questions, we'll proceed. So this was your insertion sort algorithm. Okay. কাজ করি আমরা এই যে ইয়েটা দেখানো হয়েছে এটা এবং আমাদের যে what do you call this one, আমরা যে সিকোয়েন্সটা ড্র করেছি এখানে, do the match or do they not match? Let's see. Okay, let's check. First, the input sequence was 8, 2, 4, 9, 3, 6, right, Nakina? Yeah.
Yes, sir.
Can you see 8, 2, 4, 9, 3, 6? Yes. Then
Yes,
after one iteration, the array content becomes, according to this one, 284936. Can you see it has become 284936, right? Nakina?
Yes, sir.
Yes, sir.
আচ্ছা তারপরে কি হচ্ছে it became 248936. Can you see? Check with this, the one that we have run, 248936 match করছে?
Yes, sir.
Yes, sir.
Yes, sir.
তারপরে লুপে, okay, 248936 next iteration, and you see 248936. তারপরে লুপে কি হচ্ছে 234896. You see 234896. Okay, among first next last loop 234689, and if I bring it down 234689. Match করছে নাকি ম্যাচ করছে না? Yes.
Yes, sir.
Okay, so this is what's happening, and that's what I've just shown you over here, that this is how it has sorted. The insertion sort algorithm exactly এইভাবে sort করে. So if you take an input sequence 824936, next after one iteration it will become like this, after the next iteration it will become like this, after the next iteration it will become like this, then it will become like this, and then finally like this. Because and you're done. So let's try to understand exactly কি হচ্ছে after every iteration. ঠিক আছে? Okay? All right, let's start with that. Take one. Okay, when we started our program, carefully look at that. আমরা শুরু করলাম, we started from the second index, right, Nakina? Yes?
Yes, sir.
ঠিক আছে? That's why I'm highlighting the
Hello, sir.
Can you guys hear me?
Yes, sir.
Yes, sir.
এখন
Yes, sir.
পাচ্ছি।
তখন কি মাঝখানে কেউ ইয়া করেছিল নাকি? Did it মানে একটু ইন্টারাপ্ট হয়েছিল বা সামথিং লাইক দ্যাট?
শোনা যাচ্ছিল না।
Yes.
আচ্ছা এখন আর we okay নাকি না?
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Now,
Yes, sir.
Okay, now watch this one carefully because this is important. যে এটা পর একটা iteration পর এটা কেন হলো, এটা কেন হলো, we'll try to address that. Okay, you see, first of all, when we started from which index? The second index, correct, Nakina? So
Yes,
that's
sir.
why I'm highlighting this in yellow. Now, if you're confused, go and compare with the code. J equals to কত ছিল? Initially 2. J equals to 2. J is the index number, right? So we started with index 2. Correct, Nakina? Yes?
Yes, sir.
Okay. Now, once we started with index J equals to 2, next আমরা কি করেছি, which is very important. 2 কে আমি compare করছি তার আগেরটার সাথে। আগে কে ছিল?
8.
8. So is 8 larger than 2?
Yes. Yes, sir.
আচ্ছা, sorted sequence এ আগেরটা কি হবে? Larger হবে না smaller হবে?
Smaller.
Smaller
হওয়া
one.
উচিত। But 8 is larger than 2. Because 8 is larger than 2, আমরা কি করব? আমরা 8 টাকে I'll shift it to the right, okay, and it will go in here. Clear নাকি না? Is that okay?
Yes, sir.
Yes, sir.
Okay. তারপর বলো তো 2 এর সাথে কি আর কারো কি কি বলে কম্পেয়ার করা আছে?
No, sir.
না। যেহেতু কম্পেয়ার করা নাই, I'm going to put the 2 over here, and this is going to be 4, 9, 3, 6. Is that clear নাকি না?
Yes, sir.
ঠিক আছে? Is it okay? Understandable?
Yes, sir.
ওকে, আচ্ছা, এরপর কোনটা কে নিব? এরপর আমি 4 কে নিব, রাইট? এখন তো ইনডেক্স j equals to 2 কে নিয়েছি, এরপর নেক্সট ইনডেক্স আছে 4 আছে, রাইট নাকি না? ইয়েস,
Yes, sir.
ওকে।
Yes, sir.
4 এর সাথে 8 কে কম্পেয়ার করি। Is 8 larger than 4?
Yes, sir.
Yes. So
Yes,
I'm
sir.
going to bring that 8, shift it to the right. ঠিক আছে? এই যে শিফটিং টু দ্য রাইট, এটা কোথায় হচ্ছে বলতে পারবেন? এইখানে, রাইট নাকি না? ইয়েস।
Yes, sir.
Okay, I've shifted 8 to the right, correct? 4 এর সাথে 8 compare করলাম, 8 is larger than 4, so I shifted 8 to the right. Then I'm going to compare 4 with the previous one, 2. Is 2 larger than 4?
No.
No, sir.
Because it is not, so I'm going to bring that 4, place it here. The rest of the things will remain as it is. ঠিক আছে?
Yes, sir.
নেক্সট ওয়ান কোনটার সাথে কম্পেয়ার করব? 9টার জন্য, রাইট নাকি না? ইয়েস,
Yes, sir.
ইয়া। 9 এর আগেরটা কে আছে?
8.
So tell me, is 8 larger than 9?
No.
No, sir.
Because 8 is not larger than 9, so I don't have to make any changes. 9 will stay here. 3, 6, 8 would still be here. 4 would be here. 2 would be here. Correct, Nakina? Yes. So the next one I go to is 3. ঠিক আছে? Yes. Let's compare 3 সাথে তার আগেটা 9. Is 9 larger than 3?
Yes, sir.
Yes, sir.
Okay, so I'll shift the 9 1 unit to the right, so 9 will go here. Then I compare 8 with 3. Is 8 larger than 3?
Yes, sir.
So I'm going
Yes,
to
sir.
shift the 8 1 unit to the right. এই shifting গুলো হচ্ছে এটা কোথায় হচ্ছে? এটা হচ্ছে this is happening inside this while loop, right? নাকি না? Yeah? Okay. 8 টাকে আনলাম। তারপর 4 এর সাথে compare করব। Is 4 larger than 3?
Yes, sir.
Yes,
So
sir.
I'm going to shift this 4 1 unit to the right as well. So all these things are shifted to the right. So 4 is shifted to the right as well. So 4 would come over here. Okay. Then I'm going to compare 2 with 3. Is 2 larger than 3?
No, sir.
No, sir.
So because 2 is not larger than 3, 2 would stay over here. We don't change that. But this 3 will be brought over here. Clear? And we will have 6 over here. Is it clear, Nakina?
Yes, sir.
So now the final iteration. So I'm going to compare with 6. 6, the previous one is 9. 9, is 9 larger than 6?
Yes, sir.
Yes, sir.
Bring the 9 1 unit to the right. Is 8 larger than 6?
Yes, sir.
Bring 8 1 unit to the right. Is 4 larger than 6?
No, sir.
No. So no more changes. So I'll bring this 6 here, 4 here, 3 here, 2 here as it is. Is it sorted or not?
Yes, sir. Sorted.
Yes.
So that's what is happening. Is it clear, Nakina? Are we good?
Yes, sir.
Acha. So the idea is এটাকে এখানে দেখাচ্ছে, and why do we call it an insertion sort? It's very simple. If imagine we have a card over here. This is 2, this is 4, this is 5, this is 10. We now bring another card called 7. So we're going to compare 7 with 10. Is 7 larger than 10?
No, sir.
No, sir.
No. So you shift the 10 1 unit to the right. Is 7 larger than 5? No. So you're going to put this 7 right in this place. Correct, Nakina? Yes?
Yes, sir.
Yes, sir.
So because you found the right place for this key value to be inserted, so you're going to insert this 7 right in this location. And from this word, we call this algorithm the insertion sort algorithm. Is it making sense, Nakina?
Yes, sir.
Okay. Now, what I want you guys to do is you can actually now look at this code, and I hope this will make much sense. Is it okay, Nakina? Yeah?
Yes, sir.
Yes, sir.
ঠিক আছে, বুঝতে পারছি? আচ্ছা। Okay, so I think I'm running out of time, right, Nakina? Am I running out of time? I'm probably running out of time.
Yes, sir.
Yeah, I'm probably running out of time. So I have a simple question for you, but you don't have to answer me right now. I want you to, try this one at home and tell me the answer in the next class. And the question that we have is, if someone, instead of writing AI to be greater than key, if someone writes AI greater than equal to key, what changes would the code do? Will there be any changes here? Will the code still, sort it, or will there be any kind of changes? Okay, I would like you to try out different examples, think about it carefully, ঠিক আছে? And answer me in the next class. I don't want an answer. I am not going to entertain any answer right now. I want you to really think about the algorithm. So next class আসার আগে এই algorithm নিয়ে try with different sequence. The more you do with an example, the better you will be familiar with what it does. ঠিক আছে? Is it clear, Nakina? Yeah?
Yes,
Okay.
sir.
So, and hopefully after that, I would like to hear from you. What would happen if I put it as greater than equal to instead of greater than? ঠিক আছে? I don't want an answer, even if someone knows that. I'm not going to hear it right now. Okay? Try this one at home. Okay? Get convinced. Let me know in the next class. Okay? All right?
Yes, sir.
Okay then. Thank you very much. So I'm going to, what I'm going to do,
Sir.
let me stop the recording. I don't need to put the recording on to take your attendance, right? So I can stop that,
Yes,
right?
sir. Yes, sir.